Welcome, ladies and gentlemen, to the group exhibit Hydrogen and Fuel Cells and Batteries. I'm happy to see you all here in our forum. Please have a drink on the house. Please discuss with us the next topic here on stage. It's all about size. Size matters, says Hector Maza. He's Director of Relationship Management and New Business Development of Giner Incorporated. And we will talk about megawatt stacks and PEM electrolysis, why size matters in hydrogen generation. Hector, good to see you. Good to have you here on stage.
Thank you, Uli. How are you?
How you doing?
Nice to see you.
Have a seat. So you're invited to ask any questions if you want to. Just raise your hand. I'll be with the microphone right with you. And we try to answer all of your questions, except those that are confidential, of course. Yeah,
sure.
Okay. Hector, we only see once a year. Huh? It's
right.
only here in Hanover. It's a shame, actually.
I love to come more to Europe anyway.
Last time we saw it is 1 year ago.
Yes.
What did you do all the time?
We just had fun. Actually,
right.
we've been quite busy, actually. We've been doing at Giner quite a bit of commercialization of different products. Starting by California, we have now three gas stations on the last bidders program. It was supposed to be 29 gas stations, which were pushed and developed by the CEC, the California Energy Commission. 20 of those gas stations went to just refueling stations, which are basically trucked in hydrogen. 9 of them, however, went to on-site generation. We got 3 of those 9, so we feel very, very good about it. And so that's a big deal for us. Furthermore, we are now supplying stacks for another gas station, another refueling station in south of Spain with a very large company, which will be up and running very soon. And we're also providing stacks for a very large automaker in Germany. I'm not allowed to say who it is, but people will know later on. There's an announcement. Yeah, one of the 3 big ones in Germany. And all of those have been in the multiple hundreds of kilowatt stacks. So that's decent size already.
So I've been at your booth and I've seen a 5 megawatt PEM stack there. It's huge, actually. We wanted to put it here on stage, but we couldn't handle it. Is it running already?
No. That's not running yet. That's actually a program we just started, and it's going to be running in a couple of years' time. That's obviously 5 times larger than anything you could see in this show, and we pride ourselves on being always out there, being the first ones to develop the next size up. So, as you know, we've been working on megawatt size for some time, and we're soon to release that one. But we have to test things quite a few hours before we actually claim to have tens of thousands of hours on anything. We don't like to project things out like a lot of people do. We like to actually test things for thousands of hours.
So you're working now at the 1 megawatt stack, and we have to make that clear. It's not a 1 megawatt system where you put like 4 or 8 stacks together, but it's a 1 megawatt stack. That's the special thing.
Correct.
Why do I need these big stacks? What is it good for?
Why it doesn't matter. I know it's a bad title. Well, I don't know. It's a big thing. People tend to think that you can put 100 stacks and then get to 1 megawatt, or 10 stacks, or whatever number of stacks. Size matters because it relates to cost. If you try to emulate, and we could do 1 megawatt system a year ago or 2 years ago with our Merrimack stacks, which are 150 kilowatts each. We could put 6 of them together and get to 1 megawatt. By the way, I hate to talk about megawatts. We should be talking about how many cubic meters of hydrogen we produce, because I can push 1 megawatt and produce 180 cubic meters, or I can do 1 megawatt and do 220 cubic meters, and that's quite a difference. That's 20% difference in efficiency. Yeah. But going back to your question, we could do 1 megawatt with, say, 6 stacks. Now we can do that, or very soon we'll be out there with a 1 megawatt in one system, 1 megawatt stack. That reduces the cost by 20–30%. Right. So it's a big advantage.
But it's also hard to handle, isn't it? To have you have very, very large cells, single cells.
Yes. If you're trying to do differential pressure, it's quite a big difference. It's an exponential difference, because instead of having a small membrane, say 300 centimeters squared, something like that, now you're going to more than 1,000 centimeters squared, and then the forces, the mechanical forces, are quite different, and you have to be careful when you're pushing out 40 bar, 50 bar differential pressure right at the stack. Other people choose to do balanced pressure and then pressurize the hydrogen later on, but that's complicated, it's costly. We'd rather come out at the highest possible differential pressure. There's one other company out here that might be doing differential pressure or 2, but in the end, we believe we have the best technology out there today to do that, and we're saving costs by doing that.
And it's important to say, you're producing the hydrogen by high pressure. What bar do you get? At what
How many
bar?
bars?
Yeah,
So in our commercial offering today, we offer stacks at 40 and 50 bars, differential pressure. You can run them at balanced pressure if you want, at 1 atmosphere, one bar. And in the non-commercial versions, we've done in the lab for Department of Energy up to 350 bar.
That is interesting.
Yeah.
You have 10,000 hours with 350 bars already?
No, that's why that's what we do at the lab. What we do commercially is what we have tested and we have ran for tens of thousands of hours. As I said before, we don't like to make projections and say, well, we tested this for 3,000 hours. I think it's going to last 40,000. No, we don't do that. We run it for 20,000, 30,000, and then we say it lasts 20,000 or it lasts 30,000.
Okay.
It's a different story. And on the lab scale, when you go and do hundreds of hours, yeah, it's nice. It's like a nice experiment, but then you have to warranty that. Quite a different story.
It's probably quite interesting to see where Giner is coming from. You're existing already 40 years in the market,
yes, 43.
actually.
Yeah.
So quite a long time, actually, but not many people know you. Well, some do now, but maybe 2 years ago, not so many.
Well, we pride ourselves to be a very modest company. We don't make big splashes. We really work very hard on the R&D side, and we commercialize product most of the time under NDA with our customers, and that's why sometimes I can't tell you about where these deployments are being done, but I can tell you the different countries like Germany, like Spain, like the US. But once it comes down to the specificity of who we're working with, we try to respect that on our customers, and when they want to announce it, they'll announce it. In the meantime, we just talk about the overall project. Yes, we've been in business for 43 years, and we are the only company, I think, in this fair that we can say we've been profitable all 43 years of those. And that's a little bit different story than most companies can talk about.
How could you manage that? Well, the first 20 years you only did research, didn't you?
The first 20 years we did mainly research, and the last 15 to 20 years we've been doing commercial products. And we do, today we sell thousands of small stacks into laboratory hydrogen, for example. But we're going to the boundaries of current density, size, differential pressure, efficiency, most importantly. And that's a misconception that people have sometimes. They want to go to bigger and bigger, but sometimes bigger may be the answer as long as you can produce at very high efficiency. As we know, electricity cost is very high, and it's the biggest component of the cost of hydrogen today. So if we're going to produce hydrogen, say at 7 cents per kilowatt hour, which is about 63 euros per megawatt here in Europe, which is an average price, let's say, you might be spending 40 or 50% of your actual cost of the molecule just in electricity. So the more efficient you are, the better off you are.
Sure, that's right. But back to your history, you worked for not companies, but for NASA and Ministry of Defense, who needed very reliable products. Of course, if you send 100 people down undersea, you must have a reliable electrolyzer who produces the oxygen for them, isn't it?
Absolutely. Otherwise, they die. No, it's true. Our history is based on Department of Energy, Department of Defense, NASA, the Navy, of course. We make electrolyzers for all those folks, which go to places where there's no oxygen. In that case, they don't care about hydrogen so much. They care about the oxygen side. They have a nuclear reactor. They don't need the energy.
They have energy enough.
They have enough energy to spare. But the problem is it has to be very reliable for tens of thousands of hours. And if you don't have that, people's lives are at risk. And also, very importantly, a very important piece of equipment goes down to the bottom of the ocean if that thing fails. So in the end, reliability is the name of the game, and constant reliability for decades is what makes Giner.
So you put all these things, experience from decades of doing research and doing these projects, and putting it to the market now, so the market can gain from that.
Yes, the key goal lately has been to reduce cost. As we know, Department of Defense or NASA may not need to be very, very competitive in pricing sometimes, but commercial applications do. And we're in a very competitive market. I mean, you can see around here. And our base cost has dropped 70% in the last 10 years. Is dropping again another 60 to 70% in the next 5 years. That is an amazing, an amazing improvement.
But it must have been very expensive if you dropped your prices so much.
Of course, we started very high.
Okay.
No, it's
still expensive.
It's true, but at the end of the day, we're dependent on prices of precious metals sometimes, and you can just decrease them so much. At some point, you get to the point where you can reduce them 90%, 95%, but you still need those for basic catalysts in the end, and you have to keep them into the membrane. And the membrane itself, it's not cheap. The base substrate it's a fluoropolymer, which is controlled mainly by a couple of companies out there, and there's just so much you can reduce on that.
And you have a special membrane. You call it DSM, as far as I know.
Yeah, dimensionally stable membrane, correct.
What's so special about your membrane?
Well, as we talked about earlier, you have differential pressure. Differential pressure, when you have something like Nafion, I'm sorry to get a little technical, but some of these membranes are extremely weak. So when you start putting pressure on one side, let's say the hydrogen side, and you have not enough pressure on the oxygen side, it will burst, it will actually break very easily. So you have to give some support to that membrane. Those supports is what we call the dimensionally stable membrane, to keep the membrane to a size that doesn't vary so much. When you hydrate a membrane, it changes in X, Y, and Z axis in different proportions. So you have to keep it stable, and you have to keep it supported in a way that it actually allows you to produce a high differential pressure on one side and then the other. That's
also the reason why you can handle all this 50 bar pressure,
that's
or
correct.
Even up to 350 as you.
That's correct. Yes.
I would like to give you the opportunity to ask your questions whenever you have one. Just raise your hand. I'll be with the microphone right with you. If that's not the case, we follow up with
Sure.
with my questions, of course. So what's important about electrolyzers is not what we're always talking about, like it produces so many kilowatt or whatsoever, but it's the amount of hydrogen that's coming out for the size of the whole stack.
Yes.
So it's all about efficiency in the end, isn't it?
Yes. Some people have a misconception by talking about big megawatt units, and of course, you know, there's different technologies out here. You have the PEM technology, proton exchange membrane, which is what we do. There are other technologies available, like alkaline technologies. They have their strengths and weaknesses, and we believe that PEM is way better today because of the price of electricity where it is. And some people like to make the point of how much more expensive is a PEM stack than an alkaline stack. Well, yes, it is. Of course it is. It's going to be 2, 3, 4 times more. But that's the sticker price on the stack. That doesn't mean it's more expensive at the once you get to the molecule level.
You have to see the lifetime cost, actually. You have to see
everything.
The cost for the electricity.
It's efficiency, it's maintenance, it's a balance of plant. You have a more complicated balance of plant on the alkaline system than you do on the PEM system. The efficiency is dramatically different. The current densities are dramatically different. So in the end, I can have a stack that costs 4 times more on the PEM side, and when you get to the total cost of ownership, it's actually 20% cheaper to go with PEM than to go with alkaline. So it doesn't really matter the sticker price as much as it matters the total cost of ownership of the whole piece of equipment. In the end, you're going to divide that total cost of ownership by how many kilograms of hydrogen you produce in the life, if it's 10 years or 20 years the life of that product. And in the end, you realize that you're 20 to 25, maybe 30% ahead with PEM.
But sometimes hard to see for your customers, isn't it? They say, well, I have a certain amount of money and I can only afford an alkaline.
That's correct. Well, it depends what kind of customer you have. If you have a customer that's a user, he cares how much he pays for the molecule of hydrogen. He wants to pay $5 or $4 for the kilogram of hydrogen and not 12 or 15. But if it's an engineering firm that's building a plant and is going to pass on that cost to the next guy, he only cares about the original price, and then he leaves the OPEX cost to worry for the operation guy to worry about that. So it depends who you're talking to. That's true.
And it's also a matter of size, probably. Again, you know, because for alkaline, you need a lot of space if you need high power and high efficiency and high amount of hydrogen you want to produce. And the PEM electrolyzer is much smaller, isn't it?
Well, yes, it's directly, or I would say inversely related to the current density. So if, let's say, in alkaline you run an electrolyzer at 250 or 500 milliamps per centimeter squared, and in PEM you're running it at 1,000, 2,000, or 3,000 milliamps per centimeter squared, obviously your area is going to become much smaller to produce the same amount of hydrogen. Or else you're going to be producing 6 times more hydrogen with the same amount of space. So that's where it correlates.
That's what I read at your 5 megawatt stack over there. There's written 3A. That means 3,000 milliamps.
That's exactly
what you want to reach, or did you do it already in your research laboratories?
That's what we're selling today. Our commercial offering goes at 3 amps per centimeter squared. We're selling our current Merrimack platform, which is 30 norm cubic meters of hydrogen per hour, roughly about 150 kilowatts in the small stacks. We call them small, but they're already quite large. Yeah. And they're producing about 3 kilograms of hydrogen per hour. Mm-hmm. Those are going out at 3 amps per centimeter squared. And they have been going out like that for last year, maybe a little bit more than a year.
That's the first question for Mr. Mergel.
Jürgen Mergel, Research Center Jülich. So you mentioned that you normally only developing and selling stacks.
Yes.
Also in the 30 norm cubic meter range. and now you are talking about 5 megawatt stacks.
Sure.
Does it mean that you only sell the 5 megawatt stack? Who is the customer for those stacks? Or you will also go into system development, and that means that you will sell the whole system?
Thank you.
Thank you, Mr. Merkel.
Thank you, Dr. Morgel. We actually make stacks. Let's go back a little bit. Giner used to make MEAs and sell MEAs and was happy selling MEAs. He eventually realized that there was more value add to bring a whole stack to the picture. Eventually, we realized we're doing probably ourselves a disfavor by not offering the full turnkey solution. We were approached by some of the largest gas companies and said, don't sell me a stack, I don't know what to do with it. Sell me a full system. We said, okay, we'll make the effort and make the full system for you. So it depends what kind of customer we're talking to. We will sell a stack or eventually a system. In the case of California, for example, we're offering full turnkey solution systems. In the case of my colleagues in Spain or in Germany, we were selling the stacks themselves because they are quite capable of making the balance of plant themselves. We will help them, we will collaborate with them in the balance of plant development, but they own the balance of plant in the end. And it all depends what they want and what we will sell. So today we're selling the 30 norm cubic meters of hydrogen to anyone out there. You may be aware that we are under NDA with some companies that we are not allowed to talk about, that we are on the megawatt stack development programs, and those will be taking 1, 2, maybe 5 megawatts per project. But they're going to be putting the balance of plant around that. That doesn't mean we could not use that same stack in a California gas station tomorrow, producing 210, 220 cubic meters of hydrogen per megawatt of electricity.
But Mr. Merkel also asked about your customers. Yeah, well, who will you sell these things to? You don't have to name the names, but the applications. So
sure.
You mentioned the refueling stations, which is a big application in California. What else do you do?
So there's the typical energy storage problem today in Germany and many other places. So you want to do something with that stranded power, convert it into hydrogen. So it's a good way to go so that you can actually store the energy temporarily and then convert it back either to electrons or to just basically burn it and create electricity again. So there are many ways you can go about it, but those are the main markets. You have mobility market, which is the fuel cell cars coming into California this year already with the California gas stations. You have the energy storage or energy shifting with all these windmills available in Germany, in Spain, and many other places in the world where they are stranded. They have energy they want to put out in the grid, but there's no way to put them at 2 or 3 in the morning because nobody needs it. So you store it into hydrogen. There's also another very interesting area where I believe Dr. Morgel has participated as well, where they are a different set of customers which may want to increase the efficiency of their own biomethanization projects. So right now you have a biomethanization plant that produces 50% methane, 50% CO2. What do you do with the CO2? Well, it would be very nice if you could convert that CO2 into methane. What do you need? Well, you need hydrogen, and you either need high pressure and high temperature or a very nice microbe to do the work for you. In the case of some of our customers, they've gone the way of biology. That doesn't mean it's the only way, but you can actually turn a 50% efficiency plant on the biogas plant and turn it into a 99.5 or 99.7 efficiency plant for methane production, which you then put into the pipeline and sell as methane. So that's the typical power to gas application.
Especially for these power-to-gas applications, it's another argument for PEM electrolyzers because they can handle the flow of current.
The load, yes.
That's the load. That's easier for PEMs than for alkalines, isn't it?
As far as I know, yes. My experience with alkaline is very limited, so I don't intend to be the expert in alkaline. But what I've seen in the alkaline systems that I respect, and they're incredibly big and amazing, those actually take some minutes to ramp up, some minutes to ramp down. In some cases, they take up to hours to ramp up or ramp down, depending on whether they're in standby or they're already or they're basically shut down and start from scratch. What happens is, in PEM, you can just hit the electrolyzer immediately with all the power you want, or whatever it's capable of handling, and it can go from 5% to 100% in milliseconds, and then go back down in milliseconds again. And that follows very nicely the loads that, in fact, the Department of Energy has done a study on this using our stacks, where they emulated the ramp up and down of a windmill or a solar panel, depending if a cloud comes in and blocks the sun, it goes down to 0 and then goes back up. And responding in milliseconds is a great advantage. So you can take care of every single piece of electricity that's available to you, and you don't have to wait 15 minutes or 20 or more. In the case of Germany, by the way, there's another market you were talking about now, which is supplying energy to the grid or absorbing load from the grid. And that is sold in Germany in 15-minute intervals. Well, you can take advantage of that if you have a quick reacting electrolyzer, but if you don't have that, you cannot play in that field, and you cannot buy or sell those contracts in the stock market.
Hector, unfortunately, we're running out of time.
That's
it's
okay.
already over the 20 minutes. But my last question is, I'm always very interested in reducing costs. You know, how can you further reduce costs? There is still platinum in the electrolyzers.
Yes.
Can you go without platinum one day?
Well, everybody would like to get rid of platinum, but unfortunately, you need a catalyst. We are developing alternative catalysts today. In fact, the Department of Energy has invested, and we are co-developing today different catalysts which are not included of platinum alone, but actually have an alternative way of addressing the problem. Now, these catalysts today are still as expensive as platinum, but they're performing already better than platinum. So all we have to do now is focus on reducing those costs to introduce into the marketplace. And that's very promising today. We're very excited about those projects. We have a couple of $1 million put into that today, and we'll see what happens in the next year or two.
Still some research to do. I hope you're successful,
yes.
Hector.
Yes,
Thank you very much for this talk here. Thank you for your attention. And, visit the booth of Ginner, of course, at C40. It's just opposite the technical forum. Thank you again, Hector.
Thank you very much, Uli. Thank you.
And I would like to invite you all to stay here, because just in 1 minute we have the next interview here with Magnus Dahlen. He's product manager of Nila Batteries, about nickel metal hydride batteries for industrial application, just in 1 minute. Thank you very much.